How you doing, guys? My name's Zurki Jr. and I'm with Precision Service, and in front of me is I have a Mazak M5 that we're going through for resale. We purchased the machine and we set up level. What we did is we powered the machine on and we took the X-axis slide and we put an indicator on the base and we indicate the bottom of the binder. Okay. What that does for us is able to tell me if there's any wear inside the bedways. I think it was within a half a thousandth over the whole entire distance, so it was in excellent shape. But the problem we did have is the X-axis slide was actually kind of pivoting a little bit. If you were to put an indicator on the side, you would actually see a little bit of movement. And the reason for that is when you run these machines with the Turcite material underneath this saddle weighs, is it actually dips down because you have tool pressure and tool weight itself. So over time, you're gradually going to be, this slide is going to be wearing into the spindle. So what we had to do is we had to take this off and we indicate everything and we scraped it all in. So we scraped 4.0, we scraped out the center section, we removed that. So then that way it's a nice solid set. When you indicate it off the bedways to the top of here, 4.0 is what you're looking for. After that, we, during that time, we would take the tailstock base and we use it as an indicator. So this is what I'm talking about here. We actually move this out because it's a lot lighter and we put an indicator on this. And so with the X-axis off, we would slide this all the way up forward and we put this test bar in here. And the reason why we use this test bar is we suck it in with threaded rod all the way to the back of the spindle. And then we use these 3 screws to kick around the test bar. And what you're doing when you do that is you're flipping the spindle inside out. So now with my tailstock, I indicate the front of the spindle and then the furthest away from the spindle. And when I rotate in a circle, I want to look at my indicator and make sure I'm picking up 0 as a rotation. Now once I get this test bar indicated in, then I will take my tailstock section and I will indicate the top and the side to see how true the spindle is to the bedways in reference. Now, keep in mind, when you're doing that, you're doing it off the tailstock ways. You have to do it off the X-axis ways, just to make sure they all match. But what we did find is this headstock was off by like 2.5 thousandths, and it was actually up and a little bit left for whatever reason. So when we pulled the headstock off, what we do is we did a rub. So we have a granite plate that will set the headstock on the granite plate, and we'll do a rub. You'll have Daikin blue and then the red lead on the bottom of it. And by doing that, you hand scrape the surfaces, so then that way the headstock is perfectly flat to the plate. And then what you do is you take the headstock and you print it to the base. So most often, if you crash a machine or whatever, or have an oopsie, these bolt threads kind of kick up just a little bit, and we notice that on this machine. It wasn't the end of the world, 2000s, but for us, that's way out of tolerance. So once we got this head perfectly squared up to the bedways, which would be over the top and over the side, we completed that, put that back together, and we went to the X-axis. Now, because we went with the X-axis and we had to scrape this double V's in, we actually lowered our turrets. So and also we changed our master weight here. And why that's important is because let's say if you're facing apart and I change this up by, let's say, a thou or two, you're gonna dish your parts if you're facing apart. So after we got this all figured out, in the sense of how far it was off, we had to recondition these ways right here. So that would include grinding, and then we would hand scrape this slide back to it. And while we were in there, we put a new X-axis ball screw because it was questionable. So we went ahead and bought a new one from Mazak, and we lined up the ball screw to the master way and the flat. So therefore, when you indicate the top of it and the side of it, it's completely trued up. So there's no binding at all. Whether you move the slide to the left or all the way to the right, no issues at all. And after we completed that, it was important to us to get our heights. So that's why you see this coax indicator on here. Kraus was able to bring the saddle all the way in here, sweep the section to make sure the height was right, and then we shimmed it correctly. Another time we had is we have a bar, it's usually like a 2.5 inch bar, and then we got a 1 inch bar, and you're able to do some math, and you're able to check what the height is from here to here, just to get that right on center. And then also, we replace all the seals and packings inside bolt turrets, just so you don't have any problems. It's peace of mind. You can see in the condition, it's very cleaned up machine. We went through all of X-axis. Oh, and I forgot to mention, the Z-axis ball screw. Because we brought the X-axis down a little bit, there's shim plates that fit from the X-axis to the ball screw bracket. And what we did is we measured from the end to end, because that's where our fixed points are for our ball screws. And we had to grind the shims, so then that way we were able to tuck up and we're not pushing the ball screw down, because that would cause binding. And then also with the shims on the ball screw blocks where it goes up against the base, we indicated the side, so then that way there's no binding where it's either left or right or plus or minus. So that's all taken care of. If you look around the machine, kind of walk this way, I know it's filthy and everything else, but you can see how clean this machine is. Now, we checked the motor, megged it and everything else. Everything looked great. We did put new belts in it, because why wouldn't you put new belts? And then also the input shaft. It's just important as a spindle. So what I didn't say earlier is when we had this headstock off, we went through the head. We make sure that there's no issues at all, no lift with the bearings. And the input shaft is always important to check, because it's just important as the spindle. It's get driven all the time. So we change the bearings out in there, so then that way we don't have any issues in the future for your machining operations. But it's a clean machine. I mean, you could go through it. When we do sell this machine, we are going to have our Renishaw laser calibrate the whole entire machine. Mind you though, if I do the laser compensation, if you were to move the home position, you would lose the Z-axis compensation. Because of moving the home, I had to set up on one single point, but you'll still retain it on the X-axis. But I do that just to prove, like, hey, this is my machine, this is what I stand for, and this is how accurate it is. So when you get it on your floor, you don't have any issues. It's just plug and play. If you guys have any questions about an M5 or even rebuilding your own machine, whether it's a lathe, mill, grinder, whatever it is, give us a call and we'll provide you a quote and let you know what we can do.